Welcome to Vidya Myriad. This video is made for class 9 on chapter number 1 number systems, and today we are going to do exercise 1.2 from NCERT. Question number 1. State whether the following statements are true or false and justify your answers. Number 1. Every irrational number is a real number. Now we should know what are irrational numbers and what are real numbers. Actually, the real number is made up of rational numbers as well as irrational numbers. But what is irrational numbers? These are those numbers which cannot be written in a form of P upon Q, and it is written as like root 2 is there, root 3, or the repeating numbers 0.10100100. These are irrational numbers. So the question is every irrational number is a real number. So yes, every irrational number is a real number because real number includes rational and irrational. So we will say it is a true statement. Second part. Every point on the number line is of the form root m, where m is a natural number. Now what is m? Let us find out. Let m be 2. So that means root 2. Root 2 value is 1.41421356. It goes on. So it is not a natural number. If I take m as 4, root 4 is 2, which is a natural number. So very clearly we can say is that every time when we take it on a number line, root m we take, it is not a natural number. So it is a false statement. Every real number is an irrational number. No, we know what are real numbers. Real numbers are those numbers which are made up of rational and irrational numbers. What are irrational numbers? Which cannot be written in a form of P upon Q form. So the statement they are saying is every real number is an irrational number. No, it's a false statement because real number is made up of rational and irrational. Some are rational, some are irrational. So all the real numbers are not irrational numbers. Are the square roots of all positive integers irrational? If not, give an example of the square root of a number that is a rational number. So in this case, the answer is no. The square root of all positive numbers are not irrational. How? If we take root 4 or root 9, these are the answers we are getting it as rational, that is 2 and 3. So square roots of positive integers. What are positive integers? We have taken 4 and 9. Their square roots, they are not irrational. 2 and 3 is considered as a rational numbers. Show that root 5 can be represented on the number line. Now take a scale and a pencil, draw a number line where you have the points. You start from 0 and plot 1, 2, 3 like that. On the base on the number line, we will take 2 units on the number line, and on 2 we will draw perpendicular of 1 unit. So let that 2 point be B, and on it when you draw 90 degrees, it becomes BC for 1 unit. So base is 2 unit and BC is 1 unit. Join OC. Let it be A. So AC. So ABC becomes the right angle triangle. Now base is 2. Perpendicular is 1. You can find out the hypotenuse with the help of Pythagoras theorem. So it becomes 2 square plus 1 square is equal to CA square. So CA comes out to be root 5. Now this root 5 we have to plot it on a number line. What you will do is take your compass and put it on O or A and they mark it till C. You open your compass as AC, measure AC, okay, and then from A mark it on your number line. You will get your root 5 after point 2. So that will be represented as root 5 on the number line. This is how. This was very easy. For 5 you will take 2 as your base, 2 units. On the second point you will draw 1 unit as perpendicular. Join is that hypotenuse. It become a right angle triangle. With the Pythagoras theorem you will come to know that AC comes out to be root 5. Then on A measure AC and mark it on the number line. That line will come after 2 or near 2. Okay, that point will be represented as root 5. Question number 4. Now question number 4 is a classroom activity where you have to construct the spiral of a square root, which is very interesting and very easy. Let me show you how it will look like. So it will look like this. It's beautiful presentation. You can even color it for showing it. Now how you have to start with it. You will take your base as 1 and your perpendicular as 1. When you join the hypotenuse for the beginning, the first part, your hypotenuse will become root 2. Okay, then on that point above, again you have to take the perpendicular for 1 unit. So root 2 and 1, when you take the Pythagoras theorem, your hypotenuse will become root 3. Again take a perpendicular, draw perpendicular for 1 unit. So root 3 and 1, it becomes your hypotenuse root 4. Like this and forth you will go on and the picture will come like this. Beautiful representation. You must do this, and I hope your teacher will also ask you to do, so you do it beforehand only for this. This was very simple. This is a simple presentation, step by step instructions how you have to go through it. That's all for this exercise, children. It was very simple and small exercise. I hope you must have understood. You should know what are real numbers, what are rational numbers, what are irrational numbers, and then it becomes easier for you to explain it whether the statement is true or false. Very soon I am going to come with the next exercise, children. Till then, see you children. Goodbye. Take care.